Hello, this video is for you to understand. The goal here is for you to watch this video before you come to honors chemistry in the next week or two, depending upon when your cohort meets. And the first lab of the year is the unknown powders lab. And the focus of this video is just for you to get introduced as to what the lab is and what we're looking at and what you're supposed to be doing when you show up. Since having only 2 days to complete this lab, it's very imperative that you know what you're doing and that each day you get completed what you need to. If you don't, please contact me and then we can figure out a way for me to get you the information needed so that you're ready to go for day 2. Now this first slide is just going to show you, I've got a PDF copy on the unknown powders lab activity. That this is something that you can read through. I'm not going to bore you in doing that, but it just goes through the requirements of the lab report that I'd like you to do. I have put online too a template of the unknown powders lab report, which you can easily then just download and then annotate right on it and fill it out. Use text boxes when appropriate so that you can write more information than using your finger or potentially a stylist, and then just fill it out. And then once you're complete with that, you'll submit it, but that won't occur until you're done with day 2. So this lab won't be probably turned in until the end of September, maybe potentially part of October, depending upon when your last class period is, or I should say your third class period is, or your second day of the unknown powders activity. The goal of the activity is listed right up here towards the top. And what the unknown powders lab is you are going to be given 5 powders. Each powder is, all of these are fairly common. Many of you have these in your homes even. They're labeled in a film canister A through E. The ultimate goal of this is that you're going to be given an unknown mixture on the second day in the lab, and your goal is to tell me which of those 5 powders is present in that unknown mixture. The unknown mixture could have as few as 2 of the 5 powders. It could have 4 of the 5. I'm not going to give you all 5, and I'm not going to give you just 1. So your unknown might have 2 powders in it, 3 powders, or 4. Your job is to identify which of the powders are present in it. So what you're going to do at the very end of the lab, your conclusion will be, I had unknown mixture number 12, and I determined that powders A, C, and D were present in the unknown mixture. You do not have to tell me what the powders are. Okay, so that's sometimes something I think what students fail to do or think about. All you have to do is tell me which ones are present. Now, before you can identify a mixture, you have to first know the physical and chemical properties of each of the individual powders, and that is the purpose of day 1. Day 1 is for you to build up a multitude of chemical and physical properties that you know are unique to each of the powders themselves. And then once you know those properties, then when you are given a mixture, because it's a physical mixture, because they don't react with each other, when you're given a mixture, powder A, if it's present in the mixture, its properties are still there. However, the difficulty part of this is the other powders are also present there, and their properties might mask the properties of the individual powders. Plus, the result of the mixture will not be quite as prominent because not all of the substance is that powder. It is mixed with other things. So what you want to do is identify very unique positive results in your properties that are going to cause you to clearly know when a certain powder is present based on that very unique presence. Maybe in one of the tests, only one powder turns a specific color. All the other powders do not. So if you even get a lighter shade of that color, if it turns that color, you know that powder is present. And this is much like what scientists do. In any chemical compound, once a new chemical compound is discovered, scientists will work on figuring out all of its physical and chemical properties so that if you have a substance found, maybe let's say at a crime scene, and they analyze it, they can cross-reference the properties of that substance, which is more than likely a mixture, with a database of all known chemical compounds to figure out what that mixture might be composed of. This lab, while it's fairly straightforward and very rudimentary, it still will do the basis of the same thing. We're trying to identify an unknown by knowing properties of individual pure substances. Okay, so let's turn the page. And once you've got all that data, I have a template in the unknown powders lab, which you'll fill out for your lab report that you'll finally submit electronically. but this is what your data table will look like. It's a little bit bigger so that you have more room to write in it, but you can then see of what you'll have filled out after day one. Okay, once you have all that information filled out, you are then going to make a flip chart. Not a flip chart, my bad. But you're going to make a flow chart, which is going to be a tool you're going to utilize to figure out what's in the mixture when you start mixing these substances together. And I'll have a short video on that and a how-to as to how to make the flow chart. But for now, I just want you to know what you need to have completed for day one, and hopefully it works smoothly and quickly, and to be aware of time to make sure that that table is completely filled out before you leave class for the day, and that's your main objective. Okay, thanks for listening. Again, if you have any questions, don't be afraid to give me a Canvas notification or email, or attend one of the office hours and just ask questions face-to-face with me. Okay, I hope you're going to enjoy this first lab. It's one of our labs that all of the chemistry teachers have taught it. They really enjoy it, and it's something I think that you're really going to have fun with. So thanks for listening, and we'll see you in class. Bye. So this is what you're going to see. Now at least you have some picture to look at, not just a page with lots of writing. You are going to come to class, and you are going to see a tote, which has got all the different all the different chemicals, compounds to work with. You are going to see the 5 powders labeled A through E in film canisters. You are going to have the 4 liquids, which you're going to use to test each of the powders, each of the liquids, to look for chemical properties. You are going to have a metal can lid, which you can use to heat each of the powders to find out how it responds to thermal energy. And then you also have magnifying glasses and these black strips of poster board that you can put a very thin amount of the chemical powder onto it to look for its physical properties. The last thing you're going to have are these little blue scupulas. Okay, so the blue scupula is mainly for you to use not too much powder. The number one thing I see with students is they want to use way too much. In this lab, 1 scoop, maybe 2 might be all that you need. All right, so when you come to the lab, the first thing you're going to do is take down the physical appearance of the powder. So you're going to open up each of the powders, and you're going to put a very thin amount, don't have too many of them, but put a very thin amount onto the poster board. Spread it out a little bit. Again, don't use your hands. Try to use aseptic terms. And then look at it. And you can use the magnifying glass, but take down what is its texture, what is its color, what is its shape. Is it crystalline? Is it powdery? Does it have any other type of characteristics that make it unique? And particle size. All these things you can put down. Just don't put in your data table white powder. Okay, you need to be more explicit than that, because the more specific you are in each of them, the easier it will be to figure out which of them is. Okay, so that'll be the first part of your data table. Then the next part, part 2, is you're going to test each of the powders, each of the liquids. So you have 5 powders and you have 4 liquids. So you are going to make a total of 20 individual tests. So what you see here, and if you did the lab equipment worksheet, this is a 24 well plate. So you should have more than enough wells that you can do all 20 tests. Okay, and you can make each of the combinations. So in the first well, you might do the combination of powder A plus liquid 1. Okay, and then the next well down, you would do A with 2, and so on and so forth. So I would make one column be all of the same powders. Now here again, more is not better. I would use 1 or 2 scoops max, and then if you add 1 drop of liquid and it turns a stark color, then that's all you need to add. Okay, I would not add any more than up to a maximum 5 drops of liquid. You just won't need it. Okay, so 1 or 2 scoops of each of the powders mixed with anywhere from 1 drop to as many as 5 drops. And you're looking mainly for color changes or reactivity between the powder and the liquid. Now, right now in this picture, what's bad about it is you've got a black background. I actually find a white background to be better. So what I would do is take a white piece of notebook paper and I put that white piece of paper underneath of that weld plate so that's a little bit easier for you to see any of the different colors or reactivities if they're not quite as prominent. Okay? So once you've got the test done of the liquids, you'll fill that out in your data table, and then you move to the very last thing, which is the third part of the lab, which is going to be how each of the powders responds to heat. So again, lighting the Bunsen burner safely, make sure you check your ports, use a sparker. Once you sparked it, make sure it has the nice blue flame as you can see here in the picture. You'll put a small amount, not a huge heaping amount of the powder itself. Put a small thin layer onto the can lid. Light this Bunsen burner when it's not under the can lid and then slowly slide it underneath of it and then heat it. Now, what does the powder do to the heat when heat is applied to it? Now, one thing you want to make note is the distance between the top of the Bunsen burner and the bottom of the lid. You want to keep that pretty constant because the farther or closer you get, that might change the temperature which heat the powder. So along with seeing if the powder responds to heat, another thing you might want to write down in there is how quickly it responds to heat. Does it respond to heat immediately or does it take a while? How long? Those are all things you can put down. Again, the more detail you add to it, the easier it is going to be to identify it when you make a mixture of it. Okay? So, once you're done heating the substance, I would say after a minute, after 1 minute maximum, if it has not responded to heating by then, it's not going to. By then it's several hundred degrees Celsius. If it hasn't done anything to heat, it's not going to. So once you've done with that, turn the Bunsen burner off. Use your crucible tongs, which I did not include here. Do not use your beaker tongs, but use your crucible tongs to pinch the metal lid, empty it into the wastebasket. You might want to put it underneath of your sink to cool it off and then wipe it off so there's no residue of that powder, and then add your next powder and heat it. You'll need to do that each of the 5 powders. And that's what you must complete in day 1. So you've got about an hour to do that. So physical appearance should take no more than about 5 minutes. The individual liquid testing each of the substances, again, that's going to take you a little bit of time. And then heating might take you the most time because you got to heat each individual powder solely and lighting a Bunsen burner. But the goal here is to get through all of this in day 1. So now when you are done, you have your data table completely filled out about your individual powders. What are these unique physical and chemical properties about each to help identify them? Okay? If you have any questions, again, send me an email or Canvas notification, but that's the goal of day 1. Okay? I'm going to go back and show you the first page.